The title of this note is chain rule, and the outcome is to be able to use the chain rule to find the derivative of composite functions. So here we have a function, y equals 2x minus 1 quantity squared. And we want to find the derivative of this function. Right now, the only way to do that would be to expand it out and then use our power rules. So FOILing this out, or box method, whatever works for you, we get, so this is still the definition of y, and then to find the derivative, which we're going to call dy dx, then we're going to use all of our rules. So 8x minus 4. It's fine when it's quantity squared, but what if it was quantity to the 8th power? We'd have to FOIL over and over and over again. It would get huge. So we actually have another rule for taking derivatives called the chain rule. The chain rule is used for composite functions that look like f of g of x. So when you have a function inside of another function, you can apply the chain rule. And the chain rule says you take the derivative of the first function, the outside function f, leave g in there, and then you multiply that by the derivative of g. Another way to think of this, here's f of g of x. I'm going to color code this one. You can change g of x to the letter u. That's the definition right here. U is equal to g of x. So instead of writing f of g of x, you can write it f of u. And then the derivative would be the derivative of y with respect to u times the derivative of u with respect to x. So we're going to have the same example that we started with, but now we're going to do chain rule. So this is actually composition of functions. There's an inside function in blue, and there's an outside function in green. The green function is actually x squared, and the inside function is 2x minus 1, because this is being put into this value of x to get 2x minus 1 quantity squared. So we can do the derivative. If, I'm not going to put the derivative symbol there just yet. So y is defined as f of g of x. The outside function is f, and the inside function is g. I'm just going to label these up here. So f is my green function, and g is my blue function. So the derivative will be the chain rule. It'll be the derivative of the outside function, keep the inside, times the derivative of the inside. So now I'm going to color code. The derivative of the outside function, if the outside function is x squared, the derivative is 2x. But we're not going to put x, we're going to put g of x. So that's 2x, but the input is g of x, times g prime of x. So taking the derivative of g, we get 2. So now we can simplify this. I have 2 times 2, which is 4. And I can distribute that 4 to get 8x minus 4, which is the same answer we had on the first page. So we probably didn't save any time when it was to the 2nd power, but we definitely would have saved time if it was to a higher power, like to the 4th or 5th power. So this is a chain rule where there are 2 functions. You can have a chain rule with more than 2 functions. So here's an example of a 3-link chain. So we have 3 functions. We have the tangent of x, the tangent of all of that stuff. Inside of that, we have a function 5 minus sine t. And inside the sine function, we have another function 2x. So this is like saying, I'm going to label these h is the outside function, and then inside of h, we have f And then inside of f, we have g. So the 3-link chain works the same as the 2-link chain. You just keep chain ruling. So chain rule is you take the derivative of the outside and you keep the inside. So g prime of t will be the derivative of the outside function. So the derivative of tangent x is secant squared x. But for x, I keep what's inside already. Then I multiply this by the derivative of the inside function. I'm going to move this over. So now I'm taking the derivative of what's inside of h, which is that green f stuff. So the derivative of 5 minus sine 2t. So the derivative of 5 is 0. The derivative of negative sine is negative cosine of whatever's already there. And then I'm going to go inside one more round. Take the derivative of now what's inside of there. So 2t, the derivative of 2t is 2. So this is the derivative of this entire function. That is it for our notes.